Sudoku is a logic-based number puzzle played on a 9x9 grid divided into 9 3x3 boxes. The goal is to fill the grid correctly using numbers from 1 to 9. Each row contains the numbers 1 to 9 exactly once. Each column contains the numbers 1 to 9 exactly once. Every 3x3 box has numbers 1 to 9 exactly once. There are multiple levels of this game: simple, medium, and hard. There is only one unique solution for each game. Let us play this hard version of the game. We start by observing the location for each number one at a time. For some cells, it will be possible to identify the unique number that fits there. For others, there can be multiple options. The trick is to fill the clearly identifiable numbers first, then max 2 possible cells, and then build from there. Let us start with number 1. It is there in the first and second columns of the last 3 boxes, so it has to be there in the third column of these 3 boxes. As top 2 boxes already have a 1, it has to be in third column of bottom box, which has 2 empty cells. As there is 1 in the row associated with this cell, it can be placed in only this cell, so this is definitely a 1. When playing online, mistakes are highlighted, but this is not the case when playing on paper, so have to be more careful when writing the number. Now, let us look at bottom row of boxes. There are 2 1s present in first and second row, so 1 can be present in last row of first box. As first cell already has a 1 in its column, 1 can be in one of the 2 remaining boxes, so we can write notes that one of these 2 cells will have a 1. There are already 3 1s in middle boxes row in right place. Now, let us look at top row now. In first box, it can be in only the 2 empty cells, so we can write notes here. Let us look at middle box now. Eliminating all rows and columns with 1, only 2 cells are left, and we can write notes there. We check for any other 1 we can fill in the cell. Let us now check number 2 and look for rows and columns of boxes where there are 2 2s. First column of boxes has 2 2s and 1 free cell where a 2 can be placed, so we can fill this cell directly with a 2. Let us look at the top row of boxes. There are 2s in the second and third row, so 2 can be in one of the cells of the first row of the middle box. As one cell column already has a 2 can be in the remaining cell. Similarly, for the last row, a 2 can be in only one of the remaining cell. We check if there is any other 2 that can be filled. If 8 cells of 2s are filled, then it is easy to fill the 9th one by finding the box without a 2 and eliminating rows and columns to get the right cell. Now let us select number 3 and try filling them. We see 2 possible cells for 3 and write it as notes. If there is no more solution for 3, we check number 4. Here we find a unique cell for 4. On filling it, there is only one of the 2 leftover cells for number 1. So we can update that cell also. On update of 1, we check if it solves number 1 for any other cell and update that also. With 8 cells filled for number 1, the 9th cell can be easily identified and updated. Now let us look at number 4. Looking at the top boxes row, using the elimination method, a 4 can be filled in the last box. For the last column of boxes, a 4 can be placed in one of the 2 cells, so we write notes in these cells. For first column, a position for a 4 is uniquely identified and can be filled directly. Similarly, a 4 can be placed in one of the 2 cells in the middle box, so we write it as notes in these 2 cells. Now let us see if there is any other 4 that can be filled, else we try with 5. As there is only one 5, it is difficult to fill cells based on this, so let us try with 6. In the bottom row of boxes, there are 2 cells where a 6 can be placed. We write notes there. Since there is no other clear cell for 6, let us check number 7. Second column of boxes have 2 7s. Checking the elimination method, a 7 can be placed in clear cell, which is also one of the places for number 4. Updating this cell for 7, then only one position left for 4. So this cell can also be updated for 4 directly, and notes removed. Check if the new cell numbers update solve any new cells. Two new cells identified, which can have the number 4. Checking for number 7. In first column of boxes, the unique position of 7 is visible and can be updated. Similarly, a 7 can be updated in the top row of boxes and in bottom row of boxes. With 8 cells filled for 7, it is easier to find the 9th cell for number 7, and this completes the solution for number 7. Now let us check number 8. There are only 2 cells with number 8. By elimination method, we find 2 cells with potential for 8. We write notes in that cell. Now let us check number 9. There is clear cell where a 9 can be filled in middle row of boxes. Updating this 9 makes it 2 9s in first column of boxes. Based on this, third 9 can be directly updated in the only available cell. Checking top row, there are 2 potential cells for 9 in middle box, so notes can be written in these cells. Check if there are any other cells for potential 9. Check number 3 again. In middle row of boxes, there is possibility of 3 in 2 cells, so we write notes here. Checking number 4 again, there is no new changes. If there is any box, row, or column with only one cell unfilled, then the missing number can be filled directly. If there are 8 cells filled in a box, row, or a column, the missing 2 numbers can be filled directly using elimination, or written as notes if it is not yet possible to eliminate. As number 5 and 8 are covered in first box, then this cell can only be a 6, indicating this cannot be an 8. Filling 6 here, then only one option left for 8. Which we can fill now. So this leaves 3 in only one of the cells. Checking middle row and updating missing 3 and 5 and putting them in their unique cells. Similarly, we can write notes to fill 5 and 6 in this row remaining 2 cells. Checking this column, as one empty cell has 5 or 8, then this cell will also have either 5 or 8 to complete the column. Update other rows and columns similarly. Now we can fill cells by checking for missing numbers across the box, row, and column. As you see for this cell, all 1 to 9 digits are present except 8, so we can fill 8 here. The remaining 2 cells in this box will have the missing 2 numbers, 5 and 3. So if we check this column with these 2 cells covering 5 and 3, the only missing number to be filled in the empty cell is 9. With new updates, checking the lower boxes row, there is a unique position for a 9. Similarly, a number 9 can be placed in the top row, middle box. And a 6 can be filled directly in the middle box cell. Now check all rows, columns, and boxes that have 1 or 2 cells remaining and fill them with missing numbers. As more and more cells are filled, it becomes easier to solve the remaining cells and complete the puzzle.